ScaleIO AMS 2014 provides end-to-end automation and management of a hyperconverged ScaleIO environment. AMS provides a toolkit for deploying factory-configured Dell servers, virtualized storage and compute, and VM deployment. This video includes an AMS overview and a demo of enhancements in 2014 for managing hyperconverged ESX environments. The AMS service can run on a physical or virtual machine. When it's initially installed, the administrator provides the information needed for the creation and growth of a ScaleIO cluster, such as IP address ranges for management and internal ScaleIO communication. Dell PowerEdge servers ordered as ScaleIO ready nodes arrive pre-configured to interoperate with AMS and vSphere 6.0 U3. After they boot, AMS can configure IP addresses, passwords, ScaleIO cluster membership, and physical storage media. As data center staff add storage or compute-dense servers, they can be rapidly incorporated into the system. This predictable and efficient growth is possible because the information needed for expansion is available in AMS. Wiring a new ScaleIO ready node is a standardized and documented process. All management ports are placed in the same VLAN as an AMS server. Ports carrying ScaleIO traffic are wired to dedicated data switches. The remaining 10 gigabit ports provide network access to compute resources. As the system expands, the same wiring procedures are followed for growth to a maximum size of 1,024 nodes. When storage resources are pooled with ScaleIO and the system is managed with AMS, there is enormous flexibility of virtualized storage and compute. Using AMS, a ScaleIO administrator can export raw block storage to nodes in the system. Or AMS can create or delete VMFS data stores and map them to some or all of the ESX hosts. AMS can also deploy compute environments consisting of some or all of the hosts in the ScaleIO cluster, then deploy virtual machines and storage inside of that environment. On its own, ScaleIO is exceptionally powerful software. ScaleIO with AMS provides a lot more. AMS saves time. A brand new ScaleIO ready node can be part of an evenly utilized infrastructure within hours of it arriving on the loading dock. AMS saves expertise. There's no scripting, testing, firmware configuration, or ESX image configuration required. AMS can reduce priority concerns. It provides tested workflows to reduce unplanned events. AMS provides configuration uniformity. With AMS, storage and compute resources are scaled to demand without operational complexity. Today's demo will cover new features in AMS 2014. If you're interested in some of the other features of AMS, you can find more videos on the Dell EMC website or on the ScaleIO YouTube channel. Those videos cover initial deployment, monitoring, and upgrading an AMS-managed ScaleIO system. Provisioning VMFS data stores with AMS will be covered today. Provisioning compute environments will also be covered. Finally, AMS native deployment of VMs will be covered. Today's demo will be done on a simulator, so some user interface elements and timing will differ from a production AMS 2014 system. We will begin today's demo by creating a VMFS data store. AMS eliminates the need to provision volumes from the ScaleIO GUI, then switching to vSphere to create the data stores. ScaleIO volumes will provide the raw block storage that will house the data stores. Volumes reside inside storage pools, which are elastic collections of drives distributed across the ScaleIO cluster. We'll right-click on the storage pool to create the data stores. AMS is now asking us to fill in the information needed to create the underlying volumes. We will create 3 volumes using the base name demo_vol. Now AMS needs to know which ESX host will have access to the volumes and the data stores on the volumes. AMS will then map the volumes to the hosts. AMS now provides a default naming convention for the VMFS data stores. This can be modified, but will accept the defaults. We can now view the resulting data stores natively inside the AMS GUI. Just as AMS can create a ScaleIO cluster, AMS can also create an ESX cluster and configure the application networking in the vMotion configuration. Before doing this, however, AMS needs a pool of IP addresses for use with the VM kernel NICs for vMotion. Let's define that pool now. The pool needs a name, an IP address range, and a net mask. Now we would like to create a new compute environment. In AMS 2014, a compute environment consists of an ESX cluster, compute networking, and its associated storage. We'll give this compute environment a name and specify the number of compute nodes that we use. We can specify which of the ScaleIO ready nodes to use in the compute environment, or we can allow AMS to select them for us. Let's use the magic wand to allow AMS to select the nodes for us. Under Advanced, we will specify a prefix name for the ESX cluster. The cluster needs storage. We'll specify the storage now by selecting the all-flash storage pool. Now we need to specify the advanced host level networking parameters. This system will have a single physical client data NIC. If you'll recall the red arrows on the back of the Dell PowerEdge server at the beginning of this video, this is where those ports which belong to the compute infrastructure are configured in software. Here you can specify how teaming and virtual switching will be configured, including the option for distributed virtual switches. We will now allow the use of this network port by the compute VMs. We will also allow these network ports to be used by vMotion. Note that vMotion must be enabled for AMS to do non-disruptive software upgrades. All of the parameters needed to create the compute environment have been specified, so we're ready to create the environment. While the underlying ScaleIO cluster continues running uninterrupted, AMS creates the compute environment. We can examine these operations in the command monitor. Here you can see AMS creating the ESX cluster and moving the hosts into the ESX cluster without interrupting access to the host's underlying storage, which is in use by ScaleIO. The last thing we will demo today is deployment of a virtualized workload on the compute cluster we just created. We'll start out by clicking on the resource monitor icon here. You can see the environment we just created. Let's right-click on it to deploy a workload. The wizard is asking for a template. We will select the Linux template for deployment. Other templates can of course be added to AMS as you need them. We'll give the virtual machines a base name and specify the number of VMs to be created. These VMs must reside on a VM network. We will select the network that was created when we set up the compute environment. Now that the parameters have been specified, we can deploy the virtual machines. As before, we can view the status of the operation under the command monitor. Here you can see the familiar sequence of steps involved with deploying a virtual machine, including deployment from the template, customization of the virtual machine, mapping volumes, and powering it on. Let's wrap up by reviewing the key features of ScaleIO AMS 2014. AMS automates deployment of Dell EMC ScaleIO ready nodes. These nodes are factory configured for ease of installation and are accompanied by documented procedures and support. AMS provisions storage and compute clusters by automating ScaleIO setup and compute host configuration. AMS streamlines consumption of storage and compute resources by providing workflows for ESX data store creation and virtual machine creation. AMS monitors hardware and software, providing alerts and log aggregation for the AMS managed system as a whole. AMS provides automated workflows to upgrade ScaleIO, reducing labor and risk. Finally, AMS is provided at no extra charge to customers who deploy ScaleIO using ScaleIO Ready nodes. AMS 2014 streamlines deployment, growth, and management of a hyper-converged ScaleIO and ESX environment and delivers professional-grade scalability and automation to your software-defined infrastructure.